Hello dear students, hope you're doing well. So today we have section 2 of chapter 3, in which we will talk about the structure of an atom. What does it consist of? What is inside an atom? So first know that we have anything in nature, it consists of tiny particles, or to be specific, elements. They consist of tiny particles, and we call them atoms. These atoms, or these tiny particles, they have all their chemical and physical properties of elements. So the structure of an element, we have two different main regions. We have something in the middle, we call it the nucleus, which is at the center of an atom, and it has a positive charge, and around it something that moves around it, these are electrons. So these are the two main regions. What is inside the nucleus? We have protons, which are positively charged, and we have neutrons, which are zero charged. And electrons, as we said, they're going around the nucleus, their charge is negative. But overall, the overall charge of an atom is neutral. So overall atoms, all of them, they are neutral. Why? Because protons, the number of protons are equal to number of electrons. So how many protons we have, we will have the same amount of electrons. For example, let's say we have 2 protons, so positive 2. We will have also 2 electrons, so negative 2. The total will be 0 always. These particles, we call them subatomic particles. So protons, neutrons, and electrons, all of them together, we call them subatomic particles. Now we know all of this, but before they didn't know anything about this, so they, or scientists specifically, they discovered each one of them separately. First, let's talk about the discovery of an electron, in which they used the cathode ray tube. Inside the cathode ray tube, we have, it's connected to a voltage source, so we have electricity or electric current that goes through it. When it goes through it, the surface, which is directly opposite to the cathode side, it glows. So it means something, right? And then they hypothesized that this glow was caused by a stream of particles. Something is moving inside, that's why it is glowing. They called it, back then, they called it cathode. Okay? So this cathode particle, the one that glowed, it goes from place to another place. So it goes from the cathode side, which is the negative side of this tube, goes to the positive side, which is the anode. So how does it travel? From negative to positive, from cathode to anode. All of this, after they done this experiment, they thought about a lot of things. Number one is that an object placed between the cathode and opposite end of the tube, it casts a shadow on the glass. What does that mean? It means that it have a specific size. Number two, the paddle wheels that are placed, which is right here, they moved. Because they moved, or they rolled, they went from cathode to anode. Again, going back to the reason, because these particles, they travel, they move along from cathode to anode. So it proves the previous point. Number three, the cathode rays, they were deflected by a magnetic field. The same manner as a wire carrying electric current, which was known to have a negative charge. So it goes away or deflects from a magnetic field, meaning it should have a negative charge, because electricity or the magnetic field is also negative. Because it goes away from it, it means that it repels it, right? So it should be negative. If it were to be positive, it should be attracted by this magnetic field. So what does that mean? The charge of this particle is negative. Number four, the rays were deflected away from negatively charged object. If we place a negatively charged object close to this ray, it will deflect it again, going back to the same reason, because it is negative, so it goes away from this negatively charged object. So later on, they, with their observations, they led to the hypothesis that this cathode ray, that the one they named it cathode, it is 100% negatively charged. Later on, they named it electrons. So all of this, it was supported by J.J. Thomson, which is the scientist. What was he able to conclude from this experiment? He was able to measure the ratio of the charge of the cathode ray particles to their mass, not just the charge, also the ratio of the charge to the mass of this particle, which is electron. Then Thomson, or J.J. Thomson, he concluded that all cathode rays are composed of identical negatively charged particles, which were later on they named it electrons. So no matter what they used, all of them, they had the same behavior, meaning that all particles, all atoms in nature, they have electrons. Later on, another scientist came, Millikan, Robert A. Millikan. He came and proved or discovered or measured the mass of the electron. So far we know that we have a particle, the name is electron, it's negative. Then Millikan, he measured the charge of it. Number one is that, or his experiment, it's not explained in your book, so we just have the result of his experiment, that the mass of an electron is about 1,000 the mass of the simplest atom. The simplest element in nature is hydrogen. The atomic mass is 1. If you compare this electron to this hydrogen, you'll see that the mass of electron is equal to 1/1000, close to approximately 1,000 the mass of hydrogen, more than 1,000, meaning 0.001 mass of hydrogen, which is 1. In kilograms, that's an atomic mass unit, but in kilograms, it's exactly this number. Number 2, he confirmed that the electrons, they carry a negative charge, just like Thomson did. Number 3, the electrons are present in an atom of all matter, regardless of what are they made up of. They had the same properties, meaning that all of them have electrons. So that's why they have the same behavior. So based on what we have learned about electrons, we have 2 other inferences made about the atomic structure. We have 2 other points to discuss. Number 1, because atoms are electrically neutral, meaning they have no charge, 0 charge. If you have electrons which are negative, something else should be there which should be positive in order to give us this neutral charge or 0 charge. Okay. Number 2, because electrons, they have so much less mass than atoms. This is the structure of an atom. This is electron. The mass of electron is so tiny. Then where does the other mass or the whole mass of the atom go? Something should be inside the nucleus that holds up this whole mass. Then we go to the discovery of the atomic nucleus. Another scientist did his experiment, which were Ernest Rutherford. He did the gold foil experiment. He had a thin layer of gold. He bombarded it with rays, alpha particles. Most of them went through it. Look, most of them are going through it. Some of them, only few of them, or 1 in 1,000 of these particles, they went back. So what does that mean? It means that, or he concluded that the structure of an atom is mostly empty space. That's why most particles are going through it. But some of them are coming back, right? So they are hitting something in the middle. That's why they're coming back, which later on they named it the nucleus. What were his points? That we have something in the middle which is positive, and the volume of the nucleus was very small, so mostly the atom is mostly empty space. The volume of this nucleus is very small compared to the structure of an atom. And he suggested that electrons surround the positively charged nucleus just like planets around the sun. So far, the composition of an atom or atomic nucleus. What is inside the nucleus? We have neutrons, which are 0 charge, neutral, and we have protons, which are positive. Why atoms are neutral? They have 0 charge, again because we said we have already mentioned that we have the same number of protons and electrons. So positive and negative, if they're equal, they will be equal to 0, the total charge. If you compare the mass of a proton and electron, we will see that they are slightly the same thing. So we have 1.673 powers of -7. That's for proton, neutron, 1.675 powers of -27. So they're slightly the same thing. We can just say that the mass of proton is equal to the mass of neutron. But they are much more than the mass of the electron. So the mass of the electron is the smallest out of all of them. Why atom's identity is determined by the number of protons. When we say, let's say, we have something with an atomic number of 1, it means that we have hydrogen. So it's basically telling you their identity. Why is that? Because the nuclei of an atom of different elements, they differ in the number of protons. If, let's say, we change this one into 2, we'll not have hydrogen, we'll have helium. And this is a table. We have the particles, or 3 of them, their charge and their mass. I think you're not supposed to memorize their masses. Just know that protons and neutrons, they're basically equal, but they're much more than the mass of an electron. So far we have known what is inside an atom. Then what type of forces do we have inside an atom, or inside the nucleus of an atom? Inside the nucleus we have neutrons, 0, protons, positive. Outside we have electrons going around them. So we have electrostatic forces, either attraction or repulsion. If we have the same charge, we have repulsion. So positive, positive, negative, negative, they go away from each other. But if we have positive and negative, we have attraction, attracted by each other. And this is the definition of nuclear forces. It refers to the short range between proton, neutron, proton, proton, positive, positive, and neutron, neutron forces that hold the nuclear particles together. We're not talking about electrons. Why? Because we're talking about nuclear forces. So what is inside the nucleus? We do not have electrons inside the nucleus. The last thing we have, which is the size of an atom. Atoms, they're so tiny, so you cannot just, let's say, use a ruler to measure the size of it. So what do you use? We have special units, or we have very small units in which we use to measure the radius, which is from the nucleus, the middle of the nucleus, to the outside. That's the radius of an atom. So the radius of an atom is the distance from the center, which is the nucleus, to the outside portion of this electron cloud. What units do you use? We use picometers. Okay, so 1 picometer is 10 to the power of -12 meters. So 12 zeros, then 1 meters. The range is between, so the size of an atom are mostly between 40 to 270 picometers. The smallest, which is 40, and the biggest, which is up to 270 picometers.